Okay, so welcome back. Let's have a look at taking this a bit further now for our real Soduko grid. So here we've got a particular Soduko grid. See now it's made up of 9 rows and 9 columns. So obviously I've got all my column headings going across the top there, and I've got all the various rows going down the side there. Remember what we said about the way we're going to create the list here in Python. These then are obviously our row numbers, so our row numbers will go 0, 1, 2, 3, 4, 5, 6, 7 and 8, and obviously these are our column numbers for representing our column 0, 1, 2, 3, 4, 5, 6, 7 and 8. And if you remember what we said we're going to do, we're going to form a list to represent a particular column. So there will be a list here, and that will represent column 0, and then there'll be another list, and that there will represent column 1, and so on all the way up to column 8. So we'll have a list for each of those, and then all of those lists themselves will be within a list. So we get a list of lists, and then obviously the first index will give me a particular place within a list coming across here. So the first one will tell me which of these 1, 2, 3, 4, 5, 6, 7, 8 lists I'm in. So our first number will tell me which particular column I'm in, and then the second number, once I'm within the list, will tell me how far down the list I am. So the second number will tell me which row I'm in. And if you think about this from a coordinates point of view, the column heading is a bit like the x coordinate, and the row heading is like the y coordinate. So we can think of our grid having x, y, which are our index to the lists, which will represent our position on the board. So whatever our number put in here, x, will put me in a particular column, and whatever number I put in here for y will put me in a particular row. And don't forget, obviously, the origin of this grid is this first square up here, 0, 0. Okay, so let's have a look at some code for that. Okay, so let's get our Python going. I've got an old file here, it's got nothing in at the moment, so let's put some code in here to get us going. We'll have a def main, and I'll call the main a bit further down. Okay, so let's think about our grids now. How we're going to do this. So I've got to create myself a list of lists. Now I could kind of type that list of lists, but what I actually want to do is I want to create an empty list. I want to create the grid so that I have access to all 9 by 9, all 81 elements of it. So let's just have a look how you might be tempted to do that. We can try things like this first of all. So we'll make a grid, which is obviously going to represent our board, and at the moment I'll just make that a single list. So seems to be okay. Let's just see what happens if we print that. It would help if I'd indented it. There you go. So get going again and forget the obvious. So let's run that again. Okay, so that's giving me a single list. That's kind of not particularly exciting. If I want 9 of those, actually I can do kind of times 9. Let's kind of see what that does. It looks like I want kind of this times 9. Now remember, the multiply operator does do odd things, even though this is not a mathematical an integer number and we're doing a multiplication, which is normally a mathematical process. Remember, sometimes the Python coders thought, well, times 9 probably means he wants 9 of them. So let's have a look what that does. Okay, it still seems to have printed me an empty list basically. So let's just put something in the list. Let's just put a 0 in there now and run this, see what happens now. Now there we go, that's quite interesting. What the code has now actually done, as I'm sure you can see, it's actually created a list and it's put 9 zeros in. Okay, so that seems to be quite good. That's got me a particular column in here full of zeros. So presumably, if I now put all of that inside a list, like so. So I've now put those lists inside a list, and I want 9 of those. Then let me run that and see what happens. Aha! I seem to have got my list of lists. Here we go. There's our first bracket, there's our last bracket, and each one's got 1, 2, 3, 4, 5, 6, 7, 8, 9 elements in there. So it would seem that all is well and good. I've quite easily created my list of lists. But let's have a look what happens when I do this. I'm just going to now set a particular element within the grid. So I'm going to go for the second column in, or rather the third column, which is index 2, and the fourth row down there, which is 3. I'm just going to set that to a 9 just so we can see. Actually, I'll make it a 2. That'll be quite different, and I'll reprint the grid. So this should have just altered one particular element within the grid, within the third column and the fourth row. So let's have a look what happens when we run that. Okay, so here it is. It's set the number 2 in the, I set it there. Oh no, it's gone and set it there. It's set it there. What the hell is going on here? Even though we've only specified I want one particular element within the grid being set to the number 2, it looks like it's set the first, second, third, fourth position in each of these. Now remember, this is a column, therefore each one of these represents a particular row within that column. So it looks like it's set the fourth row in column 1 and the fourth row in column 2 and so on. And this can be quite confusing. This is typical of where Python will catch you out if you're not sure what's going on. To understand what's going on here, we've got to go back to look at the code, obviously. And when we look at the code, what we realize we've done here is we created a list, and we know that works because we tried that, and then we just replicated the list 9 times. Now when you replicate a list, because of the way Python treats lists, it basically creates a copy of those 9 lists 9 times, but it doesn't create an individual copy. It actually just replicates a reference to the list. So in fact, all these lists are the same physical list, and all we've done is we've replicated the reference 9 times. So our outer list is merely a set of 9 references, all which refer to the same list. So that's not going to really get us going. We need to investigate a different way of doing this. Okay, so let's have a look how we're going to do that. We're going to use something called a generator function that you may have not come across before. So to see it in action, what we'll do is we'll just print it. I'm going to print it, get it to just generate some 2's at the moment. And basically what we do is we say for any old variable in range, however many of them I want, and I'll have 9 of them. 99 there, 9. Okay, so basically syntax is 2 for x in range and then a number here. So it will go around and it will generate these 2's however many times I've got here. So it'll generate me a list of 2's. So if I run the programs, let's see what happens. We actually get a kind of an odd report telling me it's a generator object. So it's done something, but it's not quite what we wanted. Well, the problem was what we actually generated here, we didn't do anything with it. We're generating a list of 2's, so we actually need to put that inside a list. So if I put some brackets around the outside there and close my brackets there and rerun it, you'll see what it's done now is generated a list of 2's. Okay, so what do we want to do? Well, obviously we don't want a list of 2's, we wanted a list of lists. So in here I actually put a list. And there you go, we've got our list of lists. So each of these lists here represents a particular row going across, and the which list it is our particular column. But if you think about it now, really within this list, what I want to do is I want to have spaces now for each particular row going across. So what I might do is I might go and put a 0 in there and hit run. So I've got a 0 in there, but I actually want, as we stand now, I want a separate element in here. I want this list here where there's only a 0 to actually have 9 particular elements in it, 1 for each row going across. So I need this itself replicated 9 times. So what I'm going to do is actually just take the whole list and I'm going to replicate the whole list that I've created 9 times. So at the end here I'm going to have another 4. I've used X, so I'll do Y in range 9. I've got my close there, so if I run this now, let's see what happens. Oh, misspelled range the second time round, so rerun it. And there we go. So what I've now got is I've actually got a list of lists, so one for each particular row and each particular column, and in there I've actually got a 0 in its own particular list. So that seems to be quite good. It's not quite what we had before, because we just had the number in each one of these cells before. I've now got the number within a list within the cell. I'm not too worried about that, and you'll see why we actually want that later on. So let's just check that it doesn't do what our last one did. If I now say, what obviously I need to do is I need to assign it to a variable so we can play with it. So I'm going to take away the print statement and just assign it to variable grid. I'm going to take that one off. I'm just going to check what it looks like at the moment, so I'm going to do a print grid, and then I'm going to try and alter one particular cell in there. So I'm going to do grid 2, 3, and I'm going to set it to 5. Let's have a look what happens there. Yeah, let me just bring that up where you can see it. Okay, so what's happened here? We've printed our grid, it's got all zeros, and I set grid 2, 3 to 5, but I forgot to print it, so let me print grid and rerun that. Okay, here we go. So there was our first unadulterated grid there with all zeros in, and then I changed 2, 3 to 5, and yeah, it looks like it's just changed one cell. So you can see how each cell at the moment in what we've created is actually a list within each cell, whereas there I put it just as a number 5. So I wanted the number 5 in a cell within a list, so I would maybe put a list object around there and run that. And there we go, we've got that particular cell with the number 5, and you can see it's not affected any of the other cells. So what we've been able to do now is create our lists of lists. Each cell in itself contains a list, and we can alter each of those lists within the cell. To explain why we've got this, we need to think ahead about how we talked about how we're going to solve the Soduko puzzle. And if you recall, what we said is we're going to be storing in each cell maybe the number that we know already goes in there, our known value, but for all of our other empty cells we're going to put a list of possible values that could be in there, and that's why we've actually created a list for each cell. Okay, I hope that made sense.